Hi guys. So I was asked to show how to calibrate a hydrogen 90-degree pulse without using pulse call. So I like to do that on a ZG pulse program. So it's just like a 90-degree pulse. I'm using here like a sucrose sample, but if you're using on your own sample, you could just type RGA to get the best RG. In my case, I'm not doing any water suppression because I'm just using the ZG pulse sequence. And I'm gonna calibrate the pulse looking at the water signal. So I just dropped the RG to 0.5 and I'm using a D105 and I just need one scan. So what I'm going to do is just first, so I have this like I already did the matching and tuning of the probe, the lock if you have to lock, and then the top sheen as well. By what I mean by if you have to lock is like because sometimes you're using like a prior sample that has like the same solvent and then you just like the system recognize the lock and locks away. It's like itself. So that's is the water peak, right? So what we can do from here, we can like just do DPL to set the limits. Okay. So you see like region saved. And then we just have to open like popt. I like to do like, for example, group 0, and then the parameter is like P1. And then I like to go to 0. And I'll try to do like first, actually a good way to do this is just you can like post call start with post call because then it's gonna kind of give you like if you don't have post call, then you can start from scratch. Okay. You just like um you can try like in a range of values. But if you have like for example, if you're top spinning on your top spin, you can run like pulse call, for example. Um, you can just like run tops first like pulse call, so it's 7.73 for example. So I'll grab like this number and use in like for example 7.73. So I'm gonna try to do is like what I'm gonna do is like so I grab like 9. So instead of doing like a like 90-degree pulse, I'm gonna try to make it like um a 360-degree pulse. So I'm gonna start like, for example, my starting value is gonna be 36, and there was 7, which is like 28. Like I can put even like, let's see if that's gonna. And then here, what I do is like I decrement. So you see, like I starting from the highest number, like to the highest value, and I will like decrease one by one, and then the system actually updates this for me. I'm gonna save and I will start to optimize. The system will ask if I want to proceed. And we can actually see here that starting. Mm, yeah. So you can just like come here and show all, think like, oops, inspecting, show all. And we can actually, it looks like we're like in a good point here, like that our pulse call is actually working well because I one of the my machines here, for example, when I use pulse call, it's not really well calibrated. I don't know why, but it's only for one. I haven't. I mean, by one machine, I mean like I usually run the cryo probe there all the time, and for that one, it's just the pulse call is always like 1 microsecond off. So I always calibrate using um um pops. So you can see here actually that my signal can like decay and then here in between like 32 and 33 it inverts, right? So my ideal pulse is something here in between 32, more like to 32 than 33. But we're gonna actually like just do a, so you see like, for example, the system shows that the system passed for a 0 at 31.66. That is this guy, for example, it's calibrating for me this. So what I'm gonna do, I'm gonna return there and then do like, I wanna go from, let's say you can go like from 32 to 31, sorry. And in here we go from minus 0.1. So then we have like 11 experiments, and then you save, and then you start the optimization. It's just like you want to like append override. I just want to override. So yes, and override. Yes, I can just like, so let's see. That's pretty much like what you had to do. Like you start from like um like a range where you have like from like, I don't know, 40 to, so for example, if you get Prozol and then you could try to find by yourself like the just by using like let's say that you're going to get Prozol, your pulse is like 10 microseconds, so you could try it first, check it if that is like the ideal 90-degree pulse for your sample, so you can like multiply by 4, so do you do like a 360-degree pulse, and then use ZG, and then you see if that like cancel or not. Like if you see you have like, for example, like let's say that you have still have signal, you can try, for example, going up to like 50 microseconds, and then you see if you have like an inversion or if you have actually more signal coming, and then that gives you an indication to which direction you should go. So you see here that actually I have a better I'm having like a better for example calibration of the pulse. You could actually use the first one, but I just prefer to do a more like, fine adjustment after I find kind of the rough point, because it was saying that it was 31.66, which is like a little bit like higher than it actually is. And I have a bunch of experiments because it's still like, yeah, I think it's done. So yeah, it's not very, actually it's not very far from what we got on the first experiment. So it says that it's 31.67. So we can like just get this value like 31.67 divided by 4, because this was like the 360-degree pulse. And then your pulse is like 7.918. Before was like, when we used pulse call was 7.72. So it was off like just by 0.2. But as I mentioned, like sometimes it could be off by 1 microsecond or even more than that. So it's good to like double check, especially when you're running longer experiments. Like by longer, I mean like experiments that has like for long, if you're running an experiment that has like a lot of pulses, is good. Like you must actually calibrate your pulse, so you won't lose, for example, because you can think this way: if your pulse is off by 1 microsecond on a 90-degree pulse, so it's going to be like by 2 microseconds in the 180-degree pulse. Okay, so and that can bring you like a lot of artifacts. You can lose signal. um so I hope that this actually helps you guys to better calibrate your hydrogen degree pulse, 90-degree pulse, okay? And by consequence, the other ones.